Welcome to Mrs. Riley's Maths videos. This is video 4, which was supposed to be part of video 3, but I ran out of time, so I just did video 3, and now we've got video 4 in the Surds series, and this video is about dividing surds. The method that we'll use to divide surds takes a lesson that we've learned in a previous video about what happens when we multiply a surd by itself, and we use that fact that we get a whole number, or a rational number, when we multiply a surd by itself. We get a rational number. We use that fact to divide surds. Now, just a quick review of some terms before I tell you our method. So in any fraction, we've got a numerator and a denominator. So for instance, if I had the fraction 3/5, that's the numerator, and 5 is the denominator. 3 is the numerator, 5 is the denominator. Okay, a rational number is a whole number, like the numbers that you've known since you were little: 3, 7, 11, and so on, minus 15. They're rational numbers. A half is a rational number. Any number that can be written as a fraction is a rational number. An irrational number is a number that can't be written as a fraction, and those are what these ones are called surds. Not all irrational numbers are surds, but these ones are. Okay, so this method involves us making the denominator a rational number. That's what we're aiming to do when we divide surds. We can't actually make them into just one number by itself on top of the fraction. We end up often with a fraction, but it just means that the denominator of the fraction is a rational number. And the way we do that is by using the fact that we know that if we multiply a square root, a surd, by itself, we get a rational number. Root 5 by root 5 is 5. Root 7 by root 7 is 7. We also use the fact that if we had something like, let's take 3, and we multiplied it above and below by 4, what would we end up with? We'd end up with 12 over 4, which would be 3. In other words, by multiplying it by the same thing above and below, this is something we use in maths a lot, we end up with effectively multiplying it by 1, and multiplying by something by 1 doesn't change it. So we use this fact that we can multiply something, a fraction above and below, or a number above and below, by the same number, doesn't change it, and by multiplying a surd, or an irrational number, by itself, it changes it to a rational number. So let's see what we've got here. We've got 4 root 2. To deal with this division, we would multiply above and below by root 2. Why would that be? Well, because root 2 by root 2 is root 4, which is 2. And on top then we have 4 root 2. So we have 4 root 2 over 2, which actually, if we cancel those, we get 2 root 2, and that's my answer. Sorry, I ran out of space there. Okay, so let's go through that again. 4 by root 2 is 4 root 2. Root 2 by root 2 is root 4. So on top we've got 4 root 2. Underneath we've got 2. If we divide this 2 into this 4, I get 2 root 2. This one here, I'm going to multiply it by this denominator, which is root 3, multiply above and below by root 3, because that's just the same as multiplying by 1. So on top I have root 15, and underneath I have 3, root 3 by root 3, which is 3. Can't do anything with that. Here I've got 15 over 2 root 3. I'm going to multiply above and below by 2 root 3. Actually, I probably don't need those 2's, so let's get rid of those, because they're not going to help me make it a rational number. So I've got 15 root 3. And I've got 2 by root 3 by root 3, so 2 by 3. So I have 15 root 3 over 6, and that will cancel. That'll go 3 goes into 3, that twice, 3 goes into, so I've got 5 root 3 over 2. 2 root 7 over root 5, so I'm going to multiply this time, what do you reckon? That's right, I'm going to multiply above and below by root 5. So root 5 by root 5. So what do I have on top? I've got 2 root 7 by root 5, so 2 root 35 on top. And I've got root 5 by root 5 underneath, so I've got 5 underneath. So 2/5 root 35 or 2 root 35 over 5. Here I'm going to multiply by root 14 over root 14. So what do I have? I've got 5 root 7 by root 14 is 5 root 98. Hopefully that rings a bell for you. We'll deal with it in a moment. Root 14 by root 14 is just 14. Now root 98, hopefully you've remembered that that's actually the same as the square root of 49 by 2. So what I have here, the square root of 49 by 2 is of course 5 by 7 root 2 over 14. So do you notice it's reducing, and what I end up with is 5 root 2 over 2. Okay, just talk through that one again. 5 by root 7 by root 14 is 5 root 98. Root 14 by root 14 is 14. Root 98 can be rewritten as 49 by 2. So I've got root 49. If I want to write a line here, I've got 5 root 49 root 2 over 14. Root 49 is 7. So I've got 5 by 7 root 2 over 14, and then I divided 7 into the 7 and the 14. So I've got 5 root 2 over 2. 2 over root 3 plus 1. Now this is a bit more complicated. If you remember in our previous exercise, what will change this is if I multiply it by root 3 minus 1. It's called its conjugate, and we come across that term in complex numbers as well. We're multiplying above and below by, it looks similar, but if you notice I have a plus here and a minus here. So what do I have? On top I have 2 by root 3 minus 1 over root 3 plus 1 by root 3 minus 1. So what's that give me? That gives me 2 root 3 minus 2 on top. Now, okay, I'll do it completely here, but we're going to skip this next step in the next example. Okay, root 3 by root 3 is root 9. Root 3 by minus 1 is minus root 3. Plus 1 by root 3 is plus root 3. And plus 1 by minus 1 is minus 1. So what we have is 2 root 3 minus 2 over 3, because root 9 is 3. Those go out, minus 1. So I have 2 root 3 minus 2 over 2. And then I can divide that 2 in, can't I? So 2 goes into 2 once and 2 once. Remember, when I'm dividing my denominator into my numerator here, if this is a sum rather than a product, I have to divide this number into both of these. Okay, I have to divide this 2 into both of these numbers. So I end up with root 3 minus 1. Okay, root 3 minus 1. Let's see, this 11 over 5 minus root 3. I'm going to multiply above and below by 5 plus root 3 over 5 plus root 3. So what will I have? 11 by 5 is 55 plus 11 root 3. Okay, sorry, it's gone out of focus. Okay, so multiplying above and below by 5 plus root 3. So on top I've got 55 plus 11 root 3. Underneath I've got 5 by 5, which is 25. Now remember, plus 5 root 3 and minus 5 root 3 will cancel each other out, so I'm not going to bother to put those in. And minus root 3 by root 3 is 3. So what I have here is 55 plus 11 root 3 over 22. Now, hopefully you can see that 11 is a factor of all of these. So if I divide by 11, I'll have 11 into 55 goes 5 times. 11 into 11 goes once, and 11 into 22 goes twice. So I've got 5 plus root 3 divided by 2. And the last one, I'm going to multiply above and below by 2 root 5 minus 1 over 2 root 5 minus 1. So what do I have? 1 by 2 root 5 minus 1 is just 2 root 5 minus 1. And underneath I have 2 root 5 by 2 root 5 will be 4 root 25. I'll write that because it's a bit tough to go straight to the next bit. 2 root 5 by minus 1 is minus 2 root 5. 2 root 5 plus 1 by 2 root 5 is plus 2 root 5. They'll cancel each other out. And I've got plus 1 minus 1. Plus 1 times minus 1 is minus 1. So I have 2 root 5 minus 1. 4 by 5 is 20 minus 1. So what do I have? I've got 2 root 5 minus 1 over 19. That one didn't work out as nice at all, did it? Okay, I hope that helps.